Have you ever gone online trying to find someone to help you in the preparation of GATE for food technology? Well, your search ends here. Welcome to Foodemy. Hello everyone. Today we'll be solving GATE 2018 Food Technology section. So let's look at question number 1. Which of the following is an oil-soluble pigment present in fruits and vegetables? The options are A. Flavonoids, B. Carotenoids, C. Anthocyanins, and D. Tannins. First of all, let's look at the option D. Tannins. This is not a pigment compound. This is a polyphenolic compound which has role in providing astringent tastes and are mainly responsible for astringency in grapes and pomegranate. The examples of tannins present in fruits and vegetables are gallic acid and epigallic acid. So this option is ruled out. Let's look at the option number A, flavonoids. So flavonoids is a natural secondary metabolites which are present in fruits and vegetables, and these are also polyphenols and are natural antioxidants also. Their color ranges from red, yellow to blue. Different groups are there in this flavonoid group. The subgroups are anthocyanins, chalcones, flavanols, flavonols, and these all are water soluble. So the question is asking for oil soluble. This option is also ruled out. Next option is carotenoids. These carotenoids are the pigments which are present in carrots and the sweet potato. The color ranges from red, yellow to orange, and the examples of carotenoids are alpha carotene, beta carotene, lutein, lycopene, cryptoxanthin, zeaxanthin, etc. These are the ones which are soluble in fats and oils. The last option is anthocyanin. This pigment, as I told you, is a subgroup of flavonoids. So these are present in fruits and vegetables, giving a variety of colors like red, blue and purple, and are present in various fruits and vegetables like red cabbage, strawberries, blueberries, and giving these colors to them. These are the ones which are water soluble. As I told you, all the flavonoids are water soluble. These, being a part of flavonoids, are also water soluble. So the question was asking about the ones which are soluble in oil. So the option is carotenoids. These are soluble in fats and oils. A trick to remember this pigment, how these are soluble in fats and oils, is that we know that carotenoids is a pro-vitamin A, and vitamin A is soluble in fat. These are the fat soluble vitamins. So through that you can memorize that carotenoids are also soluble in fats and oils. So the correct answer for this question is option number B. Now let's move on to the next question. Question number 2. Which of the following represents the group of saturated fatty acids? First of all, what are saturated fatty acids? Saturated fatty acids are the ones which are not having any double bond or triple bond in their structure. And all the fatty acids are being represented by a simple notation. First, writing the number of carbon atoms present in them, and then writing the number of double bonds or triple bonds present in them. Now let's look at the options given. Option A, lauric, myristic, arachidic. Lauric acid is having 12 carbon and 0 double bond or triple bond. Myristic acid is having 14 carbons and no double bond or triple bond. Arachidic acid is having 20 carbons without any double or triple bond. So here at the very moment we have got our correct option, option A, which is having all the fatty acids being saturated fatty acids without any double bond or triple bond. Option B, palmitic, linoleic and linolenic. Palmitic acid is having 16 carbons without any double bond or triple bond. Linoleic acid is having 18 carbons with 2 double bonds. These are the PUFA because they are having polyunsaturated fatty acids. They are having 2 unsaturated bonds in them. Next is linolenic acid, that is 18 carbons and 3 double bonds. Capric, steric and oleic is the third option. Capric is having 10 carbons without any unsaturated bond. Steric is having 18 carbons and oleic is having 18 carbons but 1 unsaturated bond. Last option is behenic, caprilic and arachidoic. Behenic is having 22 carbons and 0 double bond. Caprilic is having 8 carbons with 0 double bonds or triple bond, and arachidonic is having 20 carbons but 4 double bond or triple bonds. So all these options are having one or the either double bond or triple bonds in them, and thus they are having unsaturated fatty acids. So the option A is the correct answer for this question, which is having all the fatty acids as saturated fatty acids. Now let's look at question number 3. Question number 3. The anti-nutritional factor present in fava bean is, the options are gossypol, curcin, vicine and cyanogen. So first of all, let us understand what are anti-nutritional factors. Anti-nutritional factors are those which, when present in food, they inhibit or reduce the absorption or the availability of one or more nutrients. So they are obviously not wanted. All those four options given here are all the anti-nutritional factors present in various foods. Let's look at them one by one. First is gossypol. Gossypol is an anti-nutritional factor which is present in cottonseed. The trick to memorize this, whether it's present in cottonseed or other, is that cotton seeds are belonging to the genus Gossypium. So the gossypol word has come from this word. So you can remember that Gossypium, that is cotton seed, have the anti-nutritional factors called as gossypol. These gossypol are basically polyphenolic aldehydes and are yellow pigments present in the cotton seed, and they are inhibitor and toxic to the body if they are being consumed. Next anti-nutritional factor is curcine. Curcine is basically a tox albumin and is present in a type of shrub called as Jatropha curcus, and it inhibits the ribosomal activity of the host that is going to consume that product. Next is vicine. Vicine is an alkaloid glycoside which is mainly present in the fava beans, that is the question asking. And the fava beans are basically, the botanical name of fava beans is Vicia faba. So from this you can remember that vicine is present in Vicia faba, that is fava beans. Fava beans are generally called as broad beans and are consumed in northern areas of India. And these are basically causing a major disease called as favism. Favism is a hemolytic disease, that is, it is damaging the red blood cells of the human, and it may cause hemolytic anemia as well in severe cases. So vicine is the right answer, that is present in the fava beans. Along with vicine, covicine also is an anti-nutritional factor involved in the causing favism. So the last option we are left with is cyanogen. These cyanogens are present as cyanide in various food products. Basically, they are present in legumes like lima beans, and they are present in two forms: cyanogen glycosides and cyanogen lipids. Upon hydrolysis, they are definitely going to produce cyanide that is going to be very toxic for us. So, as the question asks, the anti-nutritional factor in fava bean is vicine. Let's move on to question number 4. Which of the following is gram-positive bacteria? Option A, Listeria monocytogenes. Option B, Proteus vulgaricus. Option C, Salmonella typhi. Option D, Shigella dysentery. Before moving on to the questions, let's first understand the basic difference between gram-positive bacteria and gram-negative bacteria. The basic difference lies in the cell morphology, that is their cell wall structure. The gram-positive bacteria are having a thick peptidoglycan cell wall, whereas gram-negative are lacking that. They are having a thin peptidoglycan layer. Instead, they are having an outer membrane which increases their toxicity. So please remember this as a thumb rule, that gram-negative bacteria are more toxic than gram-positive bacteria. Now let's look at the options. So how to memorize that which organisms are gram-positive and which are gram-negative bacteria? So for that, we have simple tricks to memorize. First, for gram-negative bacteria, you can remember those organisms whose names are ending with Ella. All those are gram-negative bacteria. For example, Salmonella, Shigella, Klebsiella, all those are your gram-negative bacteria. Whereas others are also there in this category. For example, E. coli, Pseudomonas, Vibrio, and Proteus. So from these lists, we can simply say that Proteus, Salmonella, and Shigella, all the three are gram-negative bacteria. For memorizing the gram-positive bacteria, two main gram-positive bacteria are Streptococci and Staphylococci. From the letter P in their words, we can memorize that these are both positive bacteria. The remaining gram-positive bacteria can be remembered easily by making acronyms such as Love Black. As you can see on the screen, all these gram-positive bacteria can be remembered very easily. Out of these 4 options, the one which is gram-positive is simply Listeria monocytogenes. So the right answer for this question is option A. Now let's move on to question number 5. Irradiation carried out to reduce viable non-spore forming pathogen bacteria using a dose between 3 to 10 kilogray is. So here in this question, irradiation process is being carried out with using a dosage of 3 to 10 kilogray to kill the viable non-spore forming pathogens. So now let's look at the question. Options: radiarization, option A. Option B is thermoradiation. Option C is radapatization, and option D is radicidation. So the question is asking for the process that is being used at this dosage. So let's look at all these processes. First process is radiarization. This process is a very simple process where the basic aim is to enhance the keeping quality of the food product. The dosage used is very low, that is 0.75 to 2.5 kilogray. So simply the keeping quality is improved. Next is thermoradiation. Thermoradiation is a simple treatment in which we are giving heat treatment as well as irradiation given to the food product. That increases the temperature of the food product. So we can use different combinations of temperature and irradiation dosages. Option C is rad appetization. So we all know about the term appetization that is being used in the canning industry. The term denotes commercial sterility or the sterilization process. So here also radiation sterilization is being done in rad appetization. This process is equivalent to any sterilization process, and the dosage used for the irradiation is very high as sterilization has to be done. 30 to 40 kilogray is the dosage that is used. Last option is radicidation. Radicidation is a process that is equivalent to pasteurization, where our main aim is to kill the viable non-spore forming pathogens. The dosage used is in the range of 2.5 to 10 kilogray. So as you can see in the question, they were asking about the dosage 3 to 10 and we're asking about killing the viable non-spore forming pathogen bacteria. That is, the process is radicidation. So the correct answer for this question is option number D. Let's move to question 6. Identify the correct statement related to the viscosity of Newtonian fluids from the following. So before moving to the options given, let's understand what are Newtonian fluids. Newtonian fluids are those fluids which follow the Newton's law of viscosity, which states that there is linear relationship between shear stress and shear rate. So Newtonian fluids will always have a linear relationship between shear stress and shear rate and will always give this straight line. The slope of this curve will give you the viscosity. So viscosity is this constant denoted by mu that will remain always constant for this graph. So this viscosity of Newtonian fluid is dependent on temperature. So if we are going to increase or decrease the temperature, viscosity is going to be affected. But the viscosity will always remain if we are changing the shearing rate. The change in shear rate is not going to impact the viscosity. Now let's move to the options. Option A is it is not influenced by temperature. So as I told you, it is influenced by temperature. So the option A is nullified. Option B is it increases with shearing rate, and option C, it decreases with shearing rate. As I told you, mu, that is viscosity, always remains constant for a particular shearing rate. So it is not going to be affected with change in shearing rate. Option D is it is not influenced by shearing rate. That is the correct option because mu is always constant for shearing rate. Now let's see question 7. Adult male Vistar rats were fed with protein-based diet. Total 150 gram of protein was ingested per animal. If the average weight increased from 110 to 350 gram after the end of experiment, the protein efficiency ratio of the given protein would be dash. So here in this question, we have been given three things. First, the amount of the protein that is supplied to the rats. Second, the increase in their weight gain, the weight gain. And lastly, they have asked us about the protein efficiency ratio. So let's just first understand what is protein efficiency ratio. Protein efficiency ratio is the weight gain in the test subject divided by the protein consumed by the test subject in the test period. So that is simply the weight gain in grams upon divided by the protein consumed. So here the weight gain is 350 minus 110 and the protein that was given was 150 gram. So the value comes out to be 1.6. So the protein efficiency ratio, the answer for this question is 1.6. Now, what is the importance of protein efficiency ratio? This is basically used to assess the quality of the proteins in different foods as a measure of the protein's ability to promote the growth in an organism. Now, let's move to question 8. The initial moisture content of a food on wet basis is 50.76%. Its moisture content on dry basis is dash. So, the question is asking for a conversion of moisture content on wet basis to a moisture content on dry basis for a particular food. Now let's first understand what is moisture content on wet basis and what is on dry basis. Moisture content on wet basis of a particular food is simply the amount of water that is present per unit mass of amount of wet sample. Whereas the moisture content on dry basis means the amount of water present per unit mass of dry samples. So for that the sample is first dried. A simple conversion of moisture content on wet basis to dry basis can be done using this formula. Moisture content on dry basis is equals to moisture content on wet basis upon 1 minus moisture content on wet basis. So let's solve this question. The moisture content on wet basis for us, the question has given us, is 50.76. That can be simply converted to 0.5076. Putting the values in this formula, it gives us the value of 1.0308. This can now be easily converted to percentage because the question is asking in percent. It is 103.08%. So the moisture content of this food, which was having the moisture content on wet basis 50.76, now has been converted to dry basis and the value is 103.08%. Now, if the question was asking about the conversion from dry basis to wet basis, a different formula can be used. It has been written here. Moisture content on wet basis is equals to moisture content on dry basis upon moisture content on dry basis plus 1. Now, let's move to question number 9. The oxygen transmission rate through a 2.54 into 10 raised to the minus 3 centimeter thick low density polyethylene film with air on one side and inert gas on the other side is 3.5 into 10 raised to the minus 6 milliliter per centimeter square cube per second. Oxygen partial pressure difference across the film is 0.21 atmosphere. The permeability coefficient of the film to oxygen is dash. So the question here is asking about the permeability coefficient of a particular film, which is LDPE, that is low density polyethylene here, and the values given are, first they have given us the thickness of the film and also they have given the oxygen transmission rate, that is 3.5 into 10 raised to the minus 6. So we have got two values, oxygen transmission rate as 3.5 into 10 raised to the minus 6 and thickness of the film, that is 2.54 into 10 raised to the minus 3 centimeters. The other thing they have told us is that on one side there is air, on the other side there is inert atmosphere. So the pressure difference here we have been given is 0.21 atmosphere. Now the interesting thing to be noted here is the unit of permeability coefficient is being given as milliliter centimeter per centimeter square per second centimeter of mercury per centimeter of mercury, but nowhere the pressure is being given into centimeter per mercury. So we have to convert that pressure into, first the 1 atmosphere is equal to 760 mm Hg, so we have to convert it into centimeter Hg as our question demands that. So that will give you 0.71 into 76 centimeter of Hg, that will give you 15.96. So these all was about the values that the question has given to us. But what are they asking? They are asking about the permeability coefficient of that film. So what is that permeability coefficient? What are they asking about? This permeability coefficient is actually a parameter of any film that is used to judge the transport flux of that film per unit driving force per unit thickness. Means how much amount of a material is being passed through that film per unit of that force, that may be the pressure difference or something else, per unit of that thickness. So the formula comes out from this definition is transmission rate, that is the flux, into thickness upon pressure difference. So all these values have already been given to us. We'll just be putting these values. So the answer comes out to be 3.5 into 10 raised to the minus 6 into the thickness, that was 2.54 into 10 raised to the minus 3 upon the pressure difference that we have just converted to centimeter of mercury, 15.96. So the value has come out to be 0.557 into 10 raised to the minus 9. But they are asking to be converted into 10 raised to the minus 11. So it will be 55.7 into 10 raised to the minus 11 milliliter centimeter per centimeter square per second per centimeter of Hg. So this is the permeability coefficient that they are asking about this LDPE. Now let's move to question 10. Ambient air at 30 degrees Celsius dry bulb temperature and 80% relative humidity was heated to a dry bulb temperature of 80 degrees Celsius in a heat exchanger by indirect heating. The amount of moisture gain in gram per kg dry air during the process would be dash. So the question is telling that air was heated in indirect heating method from a temperature of 30 degrees Celsius to 80 degrees Celsius. The air was initially having 80% relative humidity. Now the point to be noted here is that the air is being heated by indirect heating, and we must be knowing that in indirect heating there is no change in the absolute humidity. The initial and the final humidity remains the same, which indicates that there is no gain of moisture during that process. So the question was also asking about the gain in the moisture content of that air during that heating process. But as there is no gain in the moisture, the answer of this question is 0. There is no gain in the moisture. So friends, here we are done with the part A section of our food technology GATE 2018 paper. For the rest of the questions, please view the next video. Thank you for watching this video. Please like, subscribe and share. For your further queries, please drop your messages in the comment section. Thank you.